So I'd like to talk about my master thesis subject, which is about Python programming and open data for architectural design. So first, I'll give a definition of Python. So Python is a high-level programming language. It means that it's more oriented towards human comprehension instead of the computer. And its main benefits are its explicit and concise syntax and its numerous available libraries. And these libraries are like pre-written code blocks that enable the user to do a specific task without having to rewrite it. And that point is crucial because you no longer need to have a complete knowledge of the core mathematical formulas to use algorithms, as long as you understand their concept and their specific inputs and outputs. And this kind of tool is already used in numerous fields, like in geographic data. And here you have an example from the ArcGIS website, where they train a neural network to recognize buildings on aerial images. And when we look at the code for each major step, you can see that it's pretty concise, less than 10 lines long for each step. And it's concise because of those import statements you can see in the code in orange, because we call external functions that enable us to save time without rewriting complex functions. So I wondered if this tool could be also useful for architects, and what could be the potential benefits in architectural design. So I decided to challenge Python through 3 practical examples that I will show you. So the first test was quite simple. It was an extraction task from a data set about existing buildings. So I choose open data from Paris buildings, which had a lot of information about subvolumes of buildings, their height, and also information about if there are in cantilever or not. And I noticed the first issue, which is that this kind of open data have unusual formats for architects, since they are all computer-oriented data formats. Fortunately, Python has libraries like GeoPandas that provide an easy syntax to extract the informations we want. And you can see that with only 2 lines, we are able to both open the file in any of those formats I presented and extract the exact attribute we want from the dataset. And this kind of tool makes the processing data really easy for beginners. So that solves the issue we had earlier. Then I decided to transform this data back into useful documents to be used in architectural design. So I used 3 libraries to build 3 different representations. But first I sorted volumes by height. So a bit like layers, and I built I drew an interactive map with a background and a traditional CAD drawing to be imported in traditional tools, and it is on scale, also sorted by height. And since I had polylines, I had height information and cantilever informations. Why could I generate a 3D model directly? That's what I did, thanks to a 3rd library, which generates a Rhino model directly from the data. And with this example, I exploited this data to its maximum. So I was pleasantly surprised with this first approach, because it is both accurate and time savings for architects. And each one of those examples is actually under 50 lines of code. So it's pretty concise and has the advantage of being quick to run. So the second test was dedicated to build a simple neural network, like in the example predicting the roof material from aerial pictures. But since open data comes from different organisms or institutions, it means that they are on two different data sets that are not labeled the same. Fortunately, GeoPandas, the same library as we saw earlier, made me able to aggregate those data together, and I was able to use the polygon contained in the first data set to be used to extract the picture, the aerial image of the particular building from the second one, to build a whole new data set that could be used to build the model. So usually, creating a neural network requires significant knowledge about each specific neural layers you have to use in the model. And finding the right parameters for your models, like learning rate and among the other parameters, is a challenging empirical process. So I found really powerful tools. I found AutoKeras that took care of those two difficult tasks for me, and it let the user focus only on the essentials, what I want to predict and from which data. And it tries to get me the best possible model. So of course, this is a test. We have to evaluate if it's usable and if it's accurate. And so I conducted several tests, and the answer was yes. I didn't see any significant errors, and as you can see, it manages to find in all my tests the right roof materials. So between tiles, slates, concrete, and aluminum or zinc roofing. So more than the accuracy of the predictions, I was surprised by the accessibility of this approach, because I figured out that as long as you know how to process data with Python properly, even machine learning beginners can train their own prediction models with decent results, as I demonstrated. So predicting roof materials isn't very useful in architectural design. So I decided to try something more ambitious. I decided to build a neural network to help me in my diploma project design, where I had over 150 old buildings to be demolished around my site, and I had no data about, and I wanted data about the materials that I could salvage from those buildings, and I had no data whatsoever. So I had to generate them. So I was in search for data set that I could aggregate to have extensive information about existing buildings and their materials, both by quality and quantity. So I managed to get, as you can see, significant quantity of informations, more than I expected to be found in open data. And so I was able to use the same tool, GeoPandas, to build this new dataset. So I decided to base the prediction on information that I could get by myself for a few buildings, or for the 150. So I decided to split my data between one easy part and one more complicated that I wanted to predict. But as you can see, it's not like in the first example where we had one type on input and one type on output. Here you have multiple types of information. Fortunately, this is not a problem for AutoKeras, which is perfectly capable to build custom complex neural network like this with multi-types input and outputs. It's again it lets us just focus on the essentials. It requires just a bit more time to train and a bit more computer resources. So, of course, after applying, as you can see on this map, the algorithm to my 150 buildings, I decided, like the previous test, evaluate with some buildings that I selected, and I had a really satisfying accuracy. Although you can see that it could have been a bit better with more data, especially with facade materials that had some several problems. But the accuracy was, in fact, over 70%. So I was pleasantly surprised, and I decided to move on. The last step was to exploit this data in a generative design algorithm. And I decided to define my project rules, and each proposal had its own material requirements, so by material, that must be filled as much as possible with the least amount of buildings. And I was able to achieve a really optimized result, picking from the least amount of buildings and getting the more materials I could get. So, in conclusion, tools like Python enables architects to get into machine learning and design by data with a minimal knowledge requirements. And this tool is really extensive and flexible, and it proved its potential to be applied to very specific needs, which is very common in architectural design, which involves lots of specificity and a lot of special cases. And this tool is also future-proof. It's it's already in many architectural tools like Revit and Rhinos, and it will continue to be there for the future tools to come. So it's really a good investment to learn it. But we have some limits that lies in the available data of today, especially with open data that I decided to work with, which is currently quite limited to the city scale. And the scope and the content of the data really dictates what algorithm or project we can develop from it. But we can hope that as institutions push data forward, we can hope to have more diverse scopes and content about buildings to make open data and Python both valuable assets for architects. Thanks for your attention.